Okay, so now I'm going to talk about the inequality, and the inequality is the same function on the left-hand side as the equation, and the same function on the right-hand side as the equation had. So now what we want to know is, when are these y values greater than or equal to these y values? Well, we already know when they're equal. These are the x values where the two y values are equal. In fact, the y values are 0 for all of these x's. So now what we want to know is what are the x values so that the y values of this function are greater than the y values of that function. And if you recall, the cubic function is my blue graph, and the quadratic function is my red graph, the parabola. So we want, and remember that the 3 points we found had x coordinate here, which was negative 4.47. X coordinate here was negative 0.74. And the x coordinate here is positive 1.21. So if we look at this part of the blue graph, we can see that this part of the blue graph has y values that are higher than this part of the red graph, whereas this part of the blue graph has y values that are lower, under this part of the red graph. And finally, this part of the blue graph has has y values that are higher than the corresponding y values for this part of the graph. So that means that we want, since we're solving the inequality where the blue values are greater than or equal to the red values, we want the interval, the x values, for the x between from this point to this point's x value. And so that means our first interval where the blue function values are greater than the red function values is the interval from negative 4.47, the x-coordinate of our 0, to negative 0.74, the x-coordinate of the next 0. After that, the blue one is less than the red one, so we're going to jump over now, so union, and then we hit 1.21 when we start where they're equal, and then for x values that way, the y values here on the blue are always greater than the y values here on the red, always greater. So that means that we have the interval from 1.21, and it's open on the right side, it's unbounded. So, and we have the endpoints included because the greater than or equal to sign. I would like you to think about what it means to solve this inequality when you're looking at the alternate method of solution, which is to just graph the one function here and consider its zeros. So if you look at this graph, which I'm putting in this window, hope it doesn't take too long to graph. So remember, we got this graph, and this won't be a bad window to see. It's not that lovely, but it's okay. Anyway, with this graph, what's the equivalent way to find the solution when you're using this graph? And you should get the same solution. So you should have two intervals in your solution, and the question is, how do you do that from this graph? So how do you find the intervals that are the solution here for the alternate method of solution?